Okay, hi everyone. I had to change this video, that's why it's in white and not in black. Normally it'd be in black, but for time's sake, I'm just doing it again, so let's do this in white this time just to make it quicker. So we're looking at quadratic inequalities. Might have seen inequalities at GCSE before, but haven't really done kind of that much with them in terms of detail. So we're just going to go through loads of examples and a process on how things work. So the number one thing is you can't do any of these inequality problems, especially, well, any of these quadratic inequality problems or cubic or quartic or whatever without a graph. So must, let's make a note of that, must have a graph. There must be some kind of testing involved at the end for your final answer. Otherwise, no one's going to believe you that you're right, in other words. So how does this work? Well, we can, if this was an x squared minus 4x minus 5 equals 0, you would solve this in the normal way, wouldn't you? You would factorize it, but instead of it equaling 0 at the moment, it's just less than 0 still. So let's factorize that. So x minus 5, x plus 1 looks about right. Now, the difference here is that we're going to isolate something called critical values. So critical values. And what critical values means is what points, if we were to solve this thing equals 0, like the whole thing equals 0, one of these brackets would equal 0, wouldn't they? Or one of these brackets would equal, or this set of brackets would equal 0. So you would say that x equals 5 would give 0, because 0 times anything is 0, and you would say x is minus 1 would also give 0, and 0 times anything is 0. The reason they're called critical values is because it's the point, what we're interested in is when the y value is less than 0. So when the curve is less than 0. So these are critical because there are either side of 5, either the graph is going to be positive or negative. The y value is going to be positive or negative, either side of these values. So in other words, either side of these values are the tipping point between the scales, aren't they? So what do I mean by that? Well, again, we can't answer this without a graph. So we're saying x is minus 1, x is 5. Do we have a positive quadratic? Yes, because our x squared is positive. So therefore, the graph is going to look something like that, isn't it? Now, how does the inequality thing work? We're looking for when the graph is less than 0. And this is the method that I want you to do every time, okay? So let's think about it. If I put in this x value here beyond 5, so this is where we're going. We're always going from x to the graph, right? It would give me a corresponding y value up here. So this is a positive y value. Can you see? And if I extend that, make sure your quadratic's nice and big. If I put in this value of x, it gives me this corresponding value of y here, doesn't it? So this is positive, right? And this side here, so my graph should be going through minus 1, yeah? So that's minus 1. So if I put this value just to the left of minus 1, I get a positive y value. If I put this value in to my graph, I get a positive y value. But we're looking for negative y values. So this arrow technique is really nice. So this is negative, isn't it? If I put this x in here between minus 1 and 5, I get a negative y value, negative y value. And then you've got your critical values where it equals 0, right? So what are we saying? We're saying this thing is less than 0 when x is less than 5 and greater than minus 1. Can you see? X is between 5 and minus 1. And you should be able to read that to yourself because we know that means less than. If I read it to yourself, it should make sense. Minus 1 is less than 5, which it is. Therefore, we know this works. Example 2. So that's nice, that's finished. Example 2 doesn't look like in this form, but it can look like this form, can't it? We could move everything over to the left. So now it absolutely looks like a quadratic that we can solve. So like before, it looks factorizable, if that's a word. And we'll try that. So instead of having x on the left in the brackets like this, we can factorize it with it on the right, can't we? All we're trying to do is find the two brackets that when you multiply it out, it equals the same thing. So one of them's got to be a minus, one of them's got to be a plus. We're trying to make 12, so again, don't know if I'm necessarily right, but to make 4, 6 minus 2 makes 4. So should we try that? So if we make that 6 and that one 2, let's just quickly multiply that out and make sure that works. So 2 times 6 gives me 12, x times 6, so that's plus 6x, minus the 2x, minus x squared. Yes, it definitely works. So when you factorize something, we'll always expand it to check. So now we've got our critical values. What values of x will make this thing 0? Well, it's minus 2, and x is 6. So once again, we must draw the graph. No one's going to believe you if you don't have some evidence for what you're saying. So it crosses at minus 2 and 6. Is it a positive or negative quadratic? Well, it's negative, which means that instead of it being this shape, it's now this shape. So nice and big. Okay, so there's minus 2 there. And we'll do the same again. We are interested in when this thing is greater than or equal to 0. So if I put in this value of x, this gives me a corresponding value of y down here. So this is a negative y, not interested. If I put in this value of x, this gives me a corresponding negative y, not interested. Whereas this one up here, positive y, positive y, positive. So use this arrow technique to see what's going on. So again, I can see that for this thing to be positive, x needs to fall between 6 and minus 2. It's between 6 and minus 2. Read it out to yourself. Minus 2 is less than or equal to 6. So we're happy. Okay? Remember, the inequality sign stays. So if there is a less than or equal to, these need to have less than or equal to's in there as well. Let's keep going. Let's find the set of values satisfying both of these things. Okay, no problem. So if we have 4x plus 7 greater than 3, first I'm going to solve this inequality, then I'm going to solve this inequality and see where they match, see where they both are satisfied. So here, let's try and make x the subject. So 4x is greater than 3 minus 7 is minus 4. Divide everything by 4 and you get x is greater than minus 1. Could easily draw a graph on this, remember. X is minus 1 here. Normally, when you're doing just less than, you can do dotted lines. And if it's less than, sorry, more than, dotted lines, but if it's more than or equal to, you make the line solid. We won't do that, we'll just keep it as dotted because it wasn't greater than or equal to. So we're there, greater than, oh, what am I doing? Minus 1's over here anyway. So dotted line there, and then greater than minus 1 is everything to the right of minus 1. You can see it, can't you? Every single point here, x is greater than minus 1, here x is greater than minus 1, so everything is shaded. Now, let's look at this second one. Again, I want all the x's on to the correct side, so I get 17 minus 11 is 6, is less than 2x. Divide by 2, I get 3 is less than x. I find it quite hard to look at this way, so I'll just flip everything over. So that means x is bigger than 3. Can you see? 3 is less than x, so therefore, if you just flip everything out, round, mirror image it, x is greater than 3. So on my graph, I can see there's 3, dotted line because it's greater than. So x is greater than minus 1 and x is greater than 3. So if I shade this way this time, we want it to satisfy both set of inequalities. So where are they both satisfied? Where the green and the red overlap, interlace. So they both are satisfied when x is greater than 3. Can you see that? This is satisfied and this is satisfied if, sorry, and this is satisfied only if x is greater than 3. Next one. So we're just going to keep doing examples and it's all good. So like last time, we'll bring that x squared over. We'll quicken up this time. We'll factorize it. like we did before, except we got a minus this time. So this time we'll have the x and the minus x again, except now we're going to have, what are we going to have? 6 here and 2 here, and a plus here, just quick check. So that's 12 minus 6 plus 2. Yeah, it does work. So always check when you factorize. Now we've got our critical values again. So this time x is 2, x is minus 6. Quick graph. Can't do it without a graph. Minus 6 and 2. It's a negative graph, so it's going to go, I'm not sure what happened there. I'll do it over here. So minus 6 and 2, negative graph, so it's going to go something like that. Sorted. Now when is this thing bigger than 0? Because that's what we're interested. When it's bigger than 0, well, if I put this x value in, it's positive. Positive, positive. So at the moment, it's everything in there with those red arrows. But we also have to satisfy this inequality. When 5x minus 3 is greater than 2. So that means 5x is bigger than 5, which means x is bigger than 1. 1 is here, isn't it? So x is bigger than 1, dotted line. And when is x bigger than 1? All this lot, isn't it? So when are both inequalities satisfied? Well, it's where the green and the red overlap. So all this bit here, isn't it? All this bit here. So we're saying, if that's 2, we're saying x needs to fall between 1 and 2. So x is between 2 and 1. And that's the only time when that thing is satisfied. Next, let's keep going. So this time the circle C has center A, 2, 1, and will pass through the point 10, 7. Prove that the line y equals x plus 1 will intersect the circle twice. Now, first we need to know what the circle equation is. So what is the equation of the circle? We know in general, because we can't see anything until we know what the circle equation is. So A and B are the center. We know the center is 2, 1, so straight away we can write that circle as having this equation. We also need to know the point R. So quick, always drawing pictures when you're dealing with circles. So you can call it A or C for center here, and then 10, 7 for B. So we're trying to find the radius. How do you find the radius? Because we need radius squared here. Well, it's the distance between the 2 points, isn't it? So the distance CB, we know through Pythagoras, is the square root of the change in y and the change in x, all squared, added to each other. So, or in other words, x1 minus x2 all squared plus y1 minus y2 all squared. Okay? Pythagoras. So that distance there must be, because it's the x-coordinate 10, take 2 all squared plus, and now we've got our y-coordinate 7, take 1 all squared. So this must be 8 squared plus 6 squared. Sounds like 100 to me. So that means square root of 100 gives me 10. So my radius is 10, so therefore r squared is 100. Now we've got our circle. Brilliant. It's saying prove that this line, y equals x plus 1, will intersect the circle twice. So at the moment I've got my circle somewhere. We know x plus 1 is some line that goes through 1. So it's going to do something like that, intersect here or here. But we need to prove it. Now, some of you are thinking, I need to make a simultaneous equation where that equals the same as the circle. The same as because the x and the y values are the same, so therefore you can sub it in. And if you are thinking that, good for you. So substitute, exactly. Substitute x minus 2 squared plus that y and this y are the same. So that becomes x plus 1 in place there. Subtract that 1 squared is 100. So now you've got x minus 2 squared plus x plus 1 minus 1, so that's just x, squared equals 100. So therefore multiply that bracket out, just quickly expanding. Remember, if you aren't keeping up with my algebra, just stop the video and you do it all for yourself and make sure you get what's happening. So we're there. I think we're there. Okay. So again, if you disagree with anything I've done, just email me. It's easy for me to make mistakes as well as you. But I think that should be okay. So we're in that position here. Now, you could solve this on your calculator, find the 2 points, but we're trying to prove that it intersects the line twice. And what I'm getting at here is I want you to use the discriminant. So we know the discriminant for any quadratic which is in this order. So ax squared plus bx plus c describes any general quadratic. That's why you always want to put it in order of x squared, x, then number, and then you can see, because you know the discriminant is b squared minus 4ac, and we're trying to find when this thing we're trying to prove that this thing intersects the circle twice, and therefore how many roots does it have? 1, 2. So we need to show that it has 2 roots. So more, if you set your b squared minus 4ac greater than 0, then you know that describes 2 real distinct roots. So let's go for it then. So b squared, in this case, b is minus 4. So that's minus 4 all squared. Minus 4a, which is 2. Minus 4a, which is 2. And minus 96. What does that equal? You can get your calculator out. So that's 16 minus 4 times 2 times, hope you're getting your calculator out as well. So that's 106, which is bigger than 0, therefore 2 real distinct roots. And therefore crosses twice as required. Wicked. Last one then. So this one is to match more the kind of thing that's on your assignments, a bit more escalating in difficulty. So we're trying to find the range of values of k such that this thing has real roots. So remember, has real roots, we're talking about the discriminant, aren't we? So the discriminant, you probably can't read that, I'll write that again. Discriminant. Brilliant. So the discriminant, as we know, is b squared minus 4ac. Now, hopefully we know that if the discriminant is less than 0, this means no real roots. And again, hopefully you're wondering why that is, or you know why that is. And where have you seen that b squared minus 4ac before? Well, you've seen it in the quadratic formula. So this is why this whole no real roots thing has come into play, because if b squared minus 4ac is negative, you'll be square rooting a negative number, which we can't do. I know some of you might be thinking about the imaginary number I, but you're still not square rooting a negative. You can't do that. That's more technical maths, but we can talk about that later if you're doing further maths. Okay, so you can't square root a negative, therefore it doesn't have any real roots. If b squared minus 4ac equals 0, we say that has a repeated real root. Why do we say that? Well, think about it. If this thing in here equals 0, this bit in that square root, then that bit just disappears, doesn't it? So you're just left with minus b over 2a. So you just get one solution, you see? But as quadratics have 2 solutions, because you know it starts with an x squared, therefore it is 2 solutions, but they just occur at the same place. b squared minus 4ac is greater than 0 for 2 distinct real roots. That makes sense as well, doesn't it? Because if that is bigger than 0, then that means we will get a value in that square root, and we will have then a plus at square root b squared minus 4ac over 2a, and we'll also have the same but for a minus version. So there will be 2 solutions. This though says has real roots. That doesn't mean, it doesn't say whether it's repeated real roots or whether it's two distinct real roots. So therefore, be careful with that. That's where you've got this greater than or equal to signs. Means real roots. Because we don't know whether it means just one repeated real root or two real roots. So, watch out for that. So we'll use our discriminant here, but first we need to identify what's a, b, and c, because we know that ax squared plus bx plus c is 0 for any general quadratic. So we need to identify a. What's a? Well, it's the number next to x squared, so a is 1, isn't it? What's b? Well, that's the number next to, or what's called the coefficient. The coefficient means the number next to x. So this time b is minus k. So that whole section there, minus k. C though, C is anything that doesn't have an x next to it. So C is the coefficient of x to the 0. X to the 0 is 1, right? So C is the whole k plus 3. Therefore, we can start doing this problem. So A, our discriminant, b squared minus 4ac. So b squared minus 4ac is actually, b is minus k, so that's all in brackets squared, minus 4 lots of a is 1, k plus 3, and remember we're saying real roots, so that's greater than or equal to 0. We'll expand that out. Minus k all squared is k squared, minus 4 lots of k, so that's minus 4k, and then minus 4 lots of 3, and then that is minus 12. Is still greater than or equal to 0. Now we're back into a regular problem, do you see? We can't do anything without solving this thing and drawing a graph. Just a regular inequalities problem. So 6 and 2, one's going to be minus, one's going to be plus. Therefore, we're going to have critical values. When is this thing 0? When k is minus 2 and when k is 6. Quick sketch then to verify what we've done. So minus 2, 6. It's a positive quadratic. And there we go. Now we're back to our arrow method. We're looking for when this thing is bigger than or equal to 0. So if I put in an x value here, this gives me a negative y. So therefore I'm not interested. If I put this value in, I get a positive y. So positive, 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 positive. Therefore, x must be bigger than or equal to 6. You can see it, all this stuff. And x must be less than or equal to minus 2. Some of you, I know, are tempted to put this together, aren't you? Can we put it together though? Can I go, oh, x is between 6 and minus 2. I can read it aloud. I can read that as minus 2 is less than or equal to 6. But that says that x is sandwiched between minus 2 and 6. It isn't. Minus 2 and 6 is over here, isn't it? X isn't between here. The red shaded section isn't between there, so it doesn't work. Some of you are thinking, ah, well, I could write this as 6 less than like this, let's say. But let's read that out. 6 is less than or equal to minus 2. That's ridiculous. 6 is bigger than minus 2. It doesn't make any sense, you see? So you can't put everything together. I hope that's helped and cleared up some of that stuff. That's